Today, we're diving into a substance that is completely changing what a building can be. It's transforming them from just static objects into things that can react, that can adapt. And this technology, it's kind of hiding in plain sight, acting as a liquid armor for our cities, and even making the cars we drive a whole lot better. Just think about that for a second. A liquid, something that looks and feels like motor oil one moment, and in the blink of an eye, it becomes a solid with the strength of steel. And no, this isn't something out of a sci-fi movie. This is the real deal, the core of a technology that is, quite literally, liquid armor for our modern world. So you have to be wondering, right? What is this seemingly magical stuff? And how in the world does it give a massive skyscraper the reflexes to actually fight back against an earthquake? Well, let's get into it. To really understand how this is possible, we've got to look at the science behind it. This is a story of how a bizarre little discovery in a lab became something that saves lives in our biggest cities. Okay, so here's the technical term. It's called a magnetorheological fluid. Yeah, it's a mouthful. Let's just call it MR fluid. Now, it's known as a smart fluid because you can change its properties on command. And the secret ingredient? Millions and millions of microscopic iron particles, each one about the size of a single white blood cell, all just floating around in an oil-like liquid. So under normal conditions, it's nothing special at all. The little iron particles are just drifting around randomly. The fluid pours, it flows, it acts just like any other oil. You could call this its off state. But this is where the magic happens. You hit it with a magnetic field, and in milliseconds, literally milliseconds, everything changes. Those iron particles instantly snap to attention, locking together to form these incredibly strong, rigid chains. The fluid stops flowing completely. It becomes a semi-solid that can resist a huge amount of force. And then you turn the magnet off, and poof, it's a liquid again. Now here's the wild part. This technology isn't new. In fact, it was invented all the way back in 1948. But for decades, it was just a neat laboratory curiosity. A cool party trick. The problem was, while the fluid could change states, we just couldn't control it fast enough to be useful. It was an amazing invention that had to wait almost 50 years for computers and sensors to get fast enough to unlock its true potential. So how do we get from a lab curiosity to its most dramatic use case? By giving a skyscraper a nervous system. Turns out, this smart fluid solves a huge problem that has frustrated architects and engineers for centuries. And here's that classic dilemma. On the one hand, if you build a skyscraper to be incredibly rigid and strong, a massive earthquake can just snap it. But on the other hand, if you build it to be flexible so it can sway and absorb that energy, then on a really windy day, the people inside get motion sickness. You had to choose one or the other. You couldn't have both strength and flexibility. Well, until now. Here's how an MR damper works in real time. It's basically a building's reflex. First, sensors in the foundation detect the very first, fastest waves from an earthquake, called P waves. Second, a central computer instantly calculates how the building is moving and what force is needed to counter it. Third, it zaps a precise electric current to dampers placed at key joints in the building. And fourth, bam, the MR fluid inside those dampers stiffens, acting like a muscle to brace the entire structure against the shaking. The whole thing happens in the blink of an eye. Now, a really crucial point is that this is called a semi-active system. Unlike huge, power-hungry systems that try to physically push a building back into place, these MR dampers need very little electricity, sometimes just what a small battery can supply. And here's the most brilliant part. What happens if the power goes out completely during an earthquake, which, let's be honest, is pretty likely? Well, the system doesn't just fail. The fluid turns back to liquid, and the device still functions as a normal shock absorber. It's an incredibly smart, fail-safe design. Okay, so saving skyscrapers from collapsing is pretty amazing. But this technology isn't just for these rare catastrophic events. It has quietly become a kind of universal dampener, and there's a good chance you've been a lot closer to it than you think. Yup, I'm talking about the Magnetoride revolution in the car world. If you've ever wondered how a high-performance car, like a Ferrari or a Corvette, can feel incredibly smooth on a bumpy road, but also be super stiff and responsive on a racetrack, this is how. Their shock absorbers are filled with MR fluid. And get this, the car's computer can adjust the stiffness of that fluid 1,000 times every second. That's not a typo. 1,000 times. That is fast enough to make the suspension go nearly solid, to stop the car from leaning in a sharp turn, and then go instantly liquid again to soak up a pothole a split second later. It's truly adaptive technology in motion. And the applications just keep growing. We're seeing it in advanced prosthetics, where an artificial knee can use the fluid to mimic the changing resistance of a real muscle, which makes walking on stairs or uneven ground much safer. It's also being used in enormous structures like the Dongting Lake Bridge to cancel out the dangerous vibrations that high winds can cause, protecting the bridge from long-term damage. So, where is all of this going? What's the bigger picture? Well, we're really moving away from the idea of static, lifeless structures and into an era of adaptive, you might even say living, architecture. Now, of course, it wasn't a perfectly smooth ride to get here. One of the biggest problems at the beginning was that the heavy iron particles, over time, would just settle to the bottom of the fluid, kind of like sand and water. But chemists solved this with some brilliant engineering, creating special chemical coatings for the particles that act like tiny little life preservers, keeping them perfectly suspended for years and years. And this really just nails the whole shift in philosophy. The old way of thinking was to fight nature with brute force, just add more concrete, more steel. But the new way is to use intelligence. We're not building structures that can feel what's happening, process it, and react in real time. We're building them to be smarter than the forces they have to face. Which leaves us with a pretty fascinating final thought. We've given skyscrapers a nervous system. We've given cars reflexes. As these smart materials get cheaper, better, and more widespread, you have to ask yourself, what's next? What other inanimate, dead objects in our world are just waiting for their chance to wake up?